This is MSJ Chem, and in this video we look at enthalpy changes. Enthalpy change is given the symbol delta H. Here's the definition. Enthalpy change is the amount of heat absorbed or released in a chemical reaction. If the reaction is carried out under standard conditions, that's a pressure of 100 kilopascals and a temperature of 298 K, it's known as the standard enthalpy change of reaction, which is given the symbol delta H naught. The naught means it's carried out under standard conditions. Next we look at exothermic reactions. Here we have an enthalpy level diagram. On the y-axis we have enthalpy, on the x-axis we have reaction progress. For an exothermic reaction, the change in enthalpy, that's the delta H, is negative. The products have lower enthalpy than the reactants, and the products are more energetically stable than the reactants. In an exothermic reaction, heat is released. An example is combustion. Next we'll have a look at endothermic reactions. In an endothermic reaction, the delta H, that's the change in enthalpy, is positive. The products have higher enthalpy than the reactants, and the reactants are more energetically stable than the products. In an endothermic reaction, heat is absorbed. An example of an endothermic reaction is photosynthesis. So let's end with a summary. Starting with enthalpy change, an exothermic reaction has a negative enthalpy change, an endothermic reaction has a positive enthalpy change. Next, which has lower enthalpy? For an exothermic reaction, it's the products. For an endothermic reaction, it's the reactants. Which is more energetically stable? For an exothermic reaction, the products are. For an endothermic reaction, it's the reactants. And finally, is heat absorbed or released? In an exothermic reaction, heat is released. In an endothermic reaction, heat is absorbed. So that's all from this video. Don't forget, as always, to check the video description for a link to a practice worksheet.